Free response problem. Researchers are interested in whether or not women who are part of a prenatal care program give birth to babies with a higher average birth weight than those who do not take part in the program. Okay, so higher average. A random sample of hospital records indicates that the average birth weight for 75 babies born to mothers enrolled in a prenatal care program was 3,100 grams with a standard deviation of 420 grams. All right, let's make a note here. So X bar 1, 3,100, S1, 420, N1, 75. All right, a separate random sample of hospital records indicates that the average birth weight for 75 babies born to women who did not take part in a prenatal care program was 2,750 grams with a standard deviation of 425 grams. All right, so X bar 2 equals 2,750, S2 equals 425, N2 equals 75. All right, do these data provide convincing evidence that mothers who participate in a prenatal care program have babies with a higher average birth weight than those who do not? Use a significance level of 5%. All right, so notice I've already kind of got the structure here of our procedure. We're going to start with the name of the procedure. Okay, so because the 75 babies were separate random samples, that means we have two independent samples. It's not a matched pairs design. So the name of the procedure is going to be two sample t-test for mu1 minus mu2. We're interested in the difference of two population means. All right, our significance level is 5%. Our parameter, so mu1 minus mu2, represents the true difference in mean birth weight. Right. And then group 1 was the woman in the program. Group 2 was the woman not in the program. All right, so I'm defining the difference as program minus no program. Okay, our statistic. So X bar 1 minus X bar 2. 3,100 minus 2,750. It's a difference of 350 grams. Okay. Our hypotheses. Okay, so the null hypothesis is mu1 minus mu2 equals 0. So that's equivalent to saying no difference in the mean weights of these two types of babies. And then the alternative hypothesis would be mu1 minus mu2 greater than 0, which is equivalent to saying that babies from the prenatal mothers have a higher mean birth weight than the other group of babies. Okay, you could also write the hypotheses this way. You could write it as mu1 equals mu2 and mu1 greater than mu2, right? That's the null, and that's the alternative. So that's just an optional way of writing the hypotheses. Okay. All right, we have evidence because the difference in our sample is greater than 0. So that supports the alternative. Okay, so 350 is greater than 0. Okay. All right, so now let's move on to the conditions. So remember, we have separate random samples. So I'm going to write that as independent random samples. Okay, check. All right, now the 10% condition. Right, 75 is likely less than 10% of all babies born to mothers in the prenatal program. And then 75 is also less than 10% of all babies born to mothers not in the prenatal program. All right, so that satisfies the 10% rule. Okay. Also, 75 is greater than 30 for both samples. So the last condition is going to be met by the central limit theorem. Okay. All right. Calculations. General formula. This is a two-sample t-test. Well, all the tests have the same formula, right? It's a standardized test statistic that we're calculating. And the way that we calculate it is we take the statistic from our sample, or in this case, samples, minus the parameter divided by some SD. Right. Here's the specific formula. Right. You would basically construct this using the formula sheet. Okay. So the statistic is x bar 1 minus x bar 2. In fact, we already wrote the notation over here. Okay. The parameter, we already wrote the notation right there. It's mu1 minus mu2. Okay. So that part's not too bad. It's just the denominator, the standard deviation. Right. There's nowhere in our response so far that has it, so you'd have to look at the formula sheet. The standard deviation is S1 squared over N1 plus S2 squared over N2. Okay. All right, now let's plug in the numbers. So 350 was our statistic. 0 is the parameter, right? We always base it off of the null hypothesis, right? It's equivalent to saying no difference. Right, and then we need to, where are all those numbers? Okay, I'm looking at the top left of the screen. So 420 squared over 75 plus 425 squared over 75. All right, so what is that going to equal? All right, so I typed that in the calculator, and I'm getting a value of 5.07. So I'll write it over here. The test statistic is 5.07. All right, let's draw a picture. All right, so even though this is symmetric, single-peaked, and mound-shaped, this is a t-distribution, and the degrees of freedom, we're going to do this whatever is the smaller degrees of freedom. Now in this case, we're going to get the same value either way. We'll get 74 degrees of freedom if we focus on the first sample and 74 from the second sample. So it's just 74. All right, 5.07, right? So think about, this represents a result that is 5 standard deviations away from the null value, right? So 5 standard deviations would be way out over here, 5.07. And we're looking for evidence that the first group is has a higher mean than the second group. So we're going to be shading the right tail. Right. To get the p-value, I'll just use the tcdf command on the calculator. So that's second vars, option 6, tcdf. Okay. So 5.07 will be our lower bound, 999 will be the upper bound, 74 degrees of freedom. All right, so the calculator gives me 1.42 times 10 to the negative 6 power. I'm just going to write it's approximately 0. It's very, very small p-value. All right, now our conclusion. Since 0 is less than 5%, yep, 5%, we reject the null hypothesis. So we do have convincing evidence that, okay, and then now for the context, convincing evidence that mothers who participate in a prenatal program have babies with a higher average birth weight than those who do not. Okay, basically want to copy that phrase, that mothers who participate in prenatal program have babies with higher average birth weight than those who don't.